Hey there, everybody. Welcome back. We're still working on changes of parameters. We're using arc length. And this is another example we're going to want to do. The last sections had a little bit easier of examples. This one's going to be a little more challenging. Let's just jump right into it. In general, if we want S to be the arc length along the curve from T naught to T, this is our formula. I just replaced T equals 0 to T naught. So if we're not starting at T. And recall that we use the demi-variable du. So let's use R of t is sine cubed t cosine cubed t. We'll just make it 2D to make it a little bit easier. We're going to go from 0 to pi over 6 on time. You'll see why in a little while. It allows us to keep the curve smooth. So we replace r with u and take the derivative. We've got 3 sine squared u cosine u for the x component and negative 3 cosine squared u sine u for the y component. We're using the magnitude of this, so we got to square each of these, add them together, and take the square root. So what does that give us? Squaring the 3 or the negative 3 gives us 9. Squaring the squared term gives us something to the 4th power. So we got 9 sine to the 4th power u cosine squared u plus 9 cosine u to the 4th sine squared u. We can factor out a 9 and we can factor out sine squared u and cosine squared u, right? If we do, we factor out that and 2 of those leaves sine squared u. We factor out that and 2 of those, and it leaves cosine squared u. So that again is going to be 1. We have all we have left is that. Square root of this is 3 sine u cosine u. Everything was a squared term, so we want to make sure we're using the positive values. We're going to do the absolute value. I have sine u cosine u. This shows up in the double angle formula for sine. So if sine 2u equals 2 sine u, I want to end up with 3 sine u cosine u. What do I got to do? I could multiply the 2 by 3 halves, and that'll give me a 3. So multiplying by 3 halves gives me 3 sine u cosine u, and I will replace my integral with that. 3 halves sine of 2u. Okay. We integrate that. Remember to deal with the interior. It makes it another 1/2 in front. The integral of sine anything is negative cosine. So we've got negative 3/4 cosine of 2u evaluated from 0 to t. We're getting there. So cosine 2u, I don't really want to use that. Let's shift back. I want to use sine squared u, 1 minus 2 sine squared u for cosine 2u. And now we're going from u equals 0 to u equals t. So if I plug in t, I've got 1 minus 2 sine squared t. I plug in 0, I've got 1 minus 0. This is all in parentheses. Don't forget the absolute values. We've got negative 3/4 out front. I did that separately on the end. And this is why well, I guess it wasn't to keep it smooth. I said smooth earlier. On 0 to pi over 6 for t, sine is positive everywhere there. It's positive from 0 to pi over 2. We could have done something bigger. Or 0 to pi, sine's positive. But since everything is positive here, we can drop the absolute values. And we've got, oh, that's why. Pi over 6, yeah, pi over 6 matters. When we plug in sine of pi over 6, it's 1/2. And this is keeping this positive in here. We can keep it positive. So the 0 is gone. We've got 1 minus 2 sine squared t minus this one right here that's left. the ones cancel out. We've got -3/4 times -2 sine squared t, which is 3/2 sine squared t, and that's our s. Okay. Let's look at what happened with our limits, our times frame. We went from 0 to pi/6. What happens with s? We plug in 0, s is still 0. If we plug in pi/6, this is sine of 1/2, or sine of 30 degrees, which is 1/2. 1/2 squared is 1/4, times 3/2 is 3/8. So s is, or t is going, sorry, s is going from 0 to 3/8. Now we got to replace our t in our function here with s's, which means we need to solve this bad boy right here in terms of t. Well, we really want sine cubed t, right? So let's focus on sine cubed t. If I multiply both sides by 2/3, I'll get 2/3 s on the left and just sine squared t. And if I want to end up with sine cubed and I've got sine squared, I need to make it, raise it to the 3.5 power, because the 2 will cancel out the 2 and I'll have sine cubed. So I got to do that on the left. So that's what t looks like. Sine cubed t goes to 2/3 s to the 3/2 power. We want to do the same thing for cosine cubed t, because that's the y variable. So we'll make this quick substitution here with this right here. And we can still solve it. So I plug in 1 minus cosine squared t for, I can do it right here. I'll replace it right here. So I've got that turns into this for cosine. I will add cosine squared t to the left side and subtract 2/3 to the right side. That's how I got it looking like this. And then we do the 3/2 power again. So 1 minus 2/3 s to the 3/2 power is cosine cubed t. Ta-da! That's r of s. 2/3 s to the 3/2 power for x. 1 minus 2/3 s to the 3/2 power for y. And s is going from 0 to 3/8. It's not a very pretty change of parameter, but it will give us steps that might be better. Okay, that's it for that section. Peace.